Why are people spending money on electronic stud finders when there are simpler methods that can work just as well? Electronic stud finders have become the default tool for hanging heavy items, but they're not the only option. Professional carpenters and finish contractors often use alternative techniques that cost less and can be more reliable in certain situations. Let's look at the methods that have been used for generations and still work today. Strong magnets offer an interesting approach to stud finding. The concept is straightforward. Drywall screws hold your sheets to the studs, and those screws are magnetic metal running in vertical lines. Slide a strong magnet across your wall, and it can grab onto screw heads. Once you find one screw, you've potentially found the stud because standard framing uses consistent spacing. Rare earth magnets are widely available and relatively inexpensive. The magnet method works on a simple physics principle. Ferrous metal attracts magnets regardless of what's between them. This means magnets can work through various wall textures and finishes that sometimes confuse electronic sensors. Electronic stud finders can occasionally give false readings near moisture, wire, or metal plumbing, while magnets only respond to magnetic materials. The technique does have limitations. Not all fasteners are magnetic, and some walls use adhesive instead of screws in certain areas. But as a quick check method, it's worth trying before pulling out other tools. The knuckle knock technique represents traditional carpentry knowledge that predates electronic tools. Knock along your wall with your knuckles and listen for sound changes. Hollow areas between studs produce a deeper, more resonant sound. Areas directly over studs produce a higher pitched, deader sound that stops more quickly. It's similar to the difference between tapping an empty box versus tapping solid wood. Your ears can detect this change once you know what to listen for. The technique improves when you combine it with knowledge of standard framing. Studs in modern construction typically sit 16 inches apart, center to center. Find one stud with the knock test, measure 16 inches, knock again to confirm. Corner studs are reliable reference points because building code requires them at every inside and outside corner. The knock test works through paint, wallpaper, and various wall coverings. The method requires practice to develop an ear for the sound difference, and it can be less effective on walls with heavy insulation or unusual construction, but it costs nothing and works without batteries or calibration. Standard electrical outlets can reveal stud locations because electrical code has specific mounting requirements. Remove the cover plate with a screwdriver and look at which side the electrical box is mounted. Electrical boxes attached to framing, and that framing typically continues vertically. This method provides visual confirmation of framing location. Light switches work similarly. Remove the cover plate and you can see the mounting structure. This technique is particularly useful when you need to mount items near outlets or switches anyway. The outlet method has a limitation. Not all electrical boxes are mounted directly to studs. Some are mounted to blocking between studs or use old work boxes that don't attach to framing. But in many cases, especially in newer construction, the box location indicates nearby framing. Baseboards can provide clues to stud locations if you know what to look for. Where baseboards meet the wall, there may be small dimples or filled spots spaced evenly along the top edge. These are often nail holes where the baseboard was fastened during installation. Contractors typically nail baseboards into studs for secure attachment, and these fastener locations can create visible markers even when painted over. The spacing tends to be consistent because framing is consistent. These marks become more visible in certain lighting conditions. Early morning or late afternoon light hitting walls at an angle can make subtle surface variations more obvious. The baseboard method works best on older homes or homes where baseboards were installed with visible fasteners. Modern baseboard installation sometimes uses adhesive or fasteners placed differently, which can make this method less reliable, but it's worth checking, especially when mounting items low on walls. A flashlight can reveal information about wall construction through the way light interacts with surfaces. Hold a bright flashlight at a severe angle to your wall, nearly parallel to the surface, and slowly sweep it across. This raking light can reveal subtle vertical lines where drywall sheets meet at studs. Drywall seams happen at studs because that's where sheets are joined and taped. The tape and mud create very slight ridges that become more visible in angled light. This technique works better on some walls than others. Textured walls may show seams more clearly, while heavily textured or specially finished walls might might obscure them. Any bright flashlight can work for this purpose. The severe angle lighting technique also reveals other wall features, like previous repairs or surface imperfections. The method requires good lighting control. You'll need to dim or turn off room lights to see the effect clearly. A small finish nail or thumbtack can serve as a probe to confirm suspected stud locations. Once you've narrowed down a potential stud location using another method, you can push a small finish nail through the drywall at a slight angle. If it hits solid resistance within about half an inch, you've likely found framing. If it slides through easily, you're probably between studs. The holes from finish nails are quite small and can be easily filled with spackle if needed, or they'll be covered by whatever you're mounting. The finish nail method gives you physical confirmation rather than relying on electronic readings or sound. You can feel the difference between hitting solid wood versus empty space. This technique works well for verification before drilling larger holes for mounting hardware. The limitation is that you're creating small holes in your wall, which some people prefer to avoid. But for many mounting situations, these probe holes will be hidden behind the mounted item anyway. A tape measure can map your wall once you've found one stud using the consistency of standard framing. Building codes specify that studs typically sit 16 inches on center, meaning the center of one stud to the center of the next is 16 inches. Some construction uses 12-inch spacing for additional strength. Once you locate one stud through any method, your tape measure reveals where others should be. Corner locations are reliable starting points because structural framing requirements place studs at corners. Start at a corner, measure 16 inches toward the center of the wall, and that's where the next stud should be. Measure another 16 inches, and there's the next one. This mathematical approach works because framing follows consistent patterns in most construction. The method can be less reliable in older homes, renovated spaces, or areas with unusual framing around windows, doors, or architectural features. But for standard wall sections, the spacing is predictable. These alternative methods to electronic stud finders each have their place. Magnets work on simple physics, but require magnetic fasteners in the wall. Knock testing requires practice, but costs nothing. Electrical boxes show framing locations, but aren't always directly on studs. Baseboards may show fastener patterns in some homes, but not all. Flashlights reveal seams on many walls, but not every surface. Finish nails give confirmation, but create small holes. Tape measures work perfectly when framing is standard, but can't account for irregularities. Electronic stud finders have their own strengths and weaknesses. Quality models with multiple sensors can detect studs accurately through various materials. But consumer-grade models can sometimes give inconsistent readings, especially near electrical wiring, plumbing, or in walls with moisture issues. They require batteries and occasional calibration. The price range varies significantly, and cheaper models may not perform as reliably as professional-grade tools. The choice between electronic and manual methods often depends on your specific situation. For quick jobs, or when you already have a magnet or flashlight handy, alternative methods can work well. For extensive mounting projects, or if you frequently hang heavy items, investing in a quality electronic stud finder might make sense. Many professionals use a combination. They might use a stud finder for initial scanning, but verify with a finish nail probe before drilling. Others rely primarily on manual methods they've refined over years of experience. Understanding how walls are constructed helps with any stud finding method. Standard framing creates predictable patterns, and multiple verification methods can give you confidence before mounting heavy items. Let's dig deeper into how wall construction actually works, because this knowledge makes any stud finding technique more effective. Modern residential framing typically uses either 2x4 or 2x6 lumber for wall studs, depending on whether the wall is load-bearing and what climate zone the house is in. The actual dimensions of a 2x4 stud are approximately 1.5 inches by 3.5 inches. The nominal sizing versus actual sizing is something that confuses many first-time DIYers. This matters because when you're probing with a finish nail or measuring, you're looking for that 3.5 inch wide target, not a full 4 inches. The studs run vertically from the bottom plate to the top plate, creating the wall frame that gets covered with drywall or other wall materials. The 16-inch on-center spacing that we mentioned earlier isn't arbitrary. It's designed to work with standard building materials. Drywall sheets come in 4-foot widths, which is exactly 48 inches. If studs are placed every 16 inches on center, a 4-foot sheet of drywall will land on studs at 0 inches, 16 inches, 32 inches, 48 inches. This means each sheet is supported on both edges and one stud in the middle, creating a stable installation. The same logic applies to plywood sheathing on the exterior. When you understand this modular system, you can better predict where studs should be, even in rooms where you can't easily verify their location. Window and door openings disrupt the standard stud spacing, and this is where stud finding can get tricky. Around windows and doors, you'll find additional framing members: king studs that run full height beside the opening, jack studs that support the header above the opening, and cripple studs above and below windows. These additional studs mean the 16-inch spacing rule doesn't apply near openings. If you're trying to mount something near a window or door, be prepared for irregular stud spacing. The flashlight technique can be particularly useful in these areas because you may be able to see the drywall seams that indicate where extra framing exists. Exterior walls often have different construction than interior walls, and this affects stud finding. Exterior walls typically have insulation between the studs, which can make the knock test less effective because the insulation dampens the hollow sound you're listening for. The magnet method still works fine on exterior walls because the screws are on the interior drywall surface above the insulation. Exterior walls may also have additional bracing or blocking between studs for structural purposes, which can create false positives if you're not expecting them. Understanding whether you're working on an interior or exterior wall helps you interpret what your stud finding method is telling you. Older homes present unique challenges for stud finding. Houses built before the 1950s may use true dimension lumber rather than modern dimensional lumber, meaning a 2x4 might actually measure 2 inches by 4 inches. The spacing might be irregular, sometimes as wide as 24 inches on center or as narrow as 12 inches, depending on the builder's preference and local practices at the time. Balloon framing, which was common in older construction, uses studs that run continuously from foundation to roof rather than being broken at each floor level. In balloon-framed houses, you might find studs in unexpected locations. The baseboard nail method can be particularly helpful in older homes because it shows you exactly where the original builders secured the trim, regardless of whether they followed modern spacing conventions. Plaster walls, common in pre-1950s construction, add another layer of complexity. Plaster is applied over wood or metal lath, which is nailed to the studs. The magnet method works on plaster walls if the lath is metal, but the knock test can be harder to interpret because plaster creates different sounds than drywall. The plaster itself is quite hard, so the sound difference between stud locations and cavities is more subtle. Some people find that tapping with a harder object, like the handle of a screwdriver, produces a more noticeable sound difference on plaster walls. The electrical outlet method works the same on plaster as on drywall, making it a reliable fallback when other techniques are unclear. Tile walls in bathrooms and kitchens create special challenges. You can't see baseboard nails or drywall seams through ceramic tile. The knock test works, but tile sounds different than drywall, so you need to recalibrate your ear. The magnet method can work if you search near the ceiling or floor where there's a transition to drywall, then project that stud location vertically through the tiled area. Many bathroom walls have blocking between studs, specifically for mounting grab bars and towel bars, which means you might find solid wood where you don't expect it based on standard stud spacing. If you're mounting something heavy in a tiled area, the finish nail probe method can verify what you found, though you'll need to probe through a grout line to avoid damaging tiles. Commercial buildings often use metal studs instead of wood framing, which changes everything about stud finding. Metal studs are magnetic throughout their length, not just at screw locations, so a magnet will grab onto the entire stud rather than specific points. This actually makes the magnet method more effective in commercial spaces. The knock test works differently. Metal studs create a distinctive ringing sound when tapped that's very different from hollow cavity sounds. If you're working in an office or commercial space, be aware that metal framing is common and adjust your expectations accordingly. The relationship between studs and other building elements provides additional clues. Electrical outlets aren't randomly placed. Code requires them at specific intervals along walls, and electricians typically mount them to studs or to blocking between studs. If you found one outlet mounted on a stud and the next outlet is about 6 to 8 feet away, there are likely several studs between them following the 16-inch pattern. Ceiling fixtures, wall sconces, and switches all mount to framing, so these elements give you reference points. A wall sconce is definitely attached to something solid, even if it's blocking rather than a regular stud. HVAC registers and cold air returns are cut into walls at framing locations. If you have a floor register along a wall, the framing around that opening shows you stud locations. The same applies to built-in features like medicine cabinets, which are typically framed into the wall between studs. These architectural elements provide free information about the framing behind your walls if you know how to read them. Mounting heavy items safely requires understanding load distribution. A single screw into a stud can typically hold significant weight, but the exact amount depends on the screw type, the wood species and condition, and the angle of the load. Lag screws driven into studs can support more weight than standard wood screws. Toggle bolts that spread the load across a larger area of drywall can work for medium weight items even between studs, but they're not appropriate for very heavy objects. When mounting something that weighs more than about 30 pounds, finding studs becomes important for safety. The multiple verification approach makes sense for heavy items. Use a magnet or knock test to locate a probable stud. Verify with a finish nail probe, then measure from that confirmed location to find additional studs for multiple mounting points. The height at which you're mounting items affects your strategy. Items mounted near the ceiling or floor might let you use the baseboard or crown molding method, while items mounted at mid-wall height work better with the electrical outlet or knock test approach. Very heavy items like wall-mounted televisions benefit from mounting brackets that span multiple studs, which means you need to find at least 2 studs with accurate spacing between them. The measurement method becomes critical here. Find one stud reliably, measure 16 inches, verify the second location, and you're ready to mount a bracket with confidence. Studs aren't the only framing members in walls. Horizontal blocking, fire stops, and nailers may exist between studs, especially in older construction or around specific features. If your magnet finds a horizontal line of screws rather than a vertical line, you've probably found blocking. This can actually be useful for mounting certain items like shelving or curtain rods, where horizontal support is exactly what you need. Don't assume every solid spot you find is a vertical stud. Walls contain various framing elements serving different purposes. Weather and environmental factors can affect stud finding. In humid climates, moisture in walls can sometimes affect electronic stud finders, causing false readings. The manual methods we've discussed don't have this problem. Magnets, knock tests, and visual inspection work regardless of humidity. In very cold climates, ice dams and water infiltration can affect wall conditions, but the basic framing remains in standard locations. Understanding your local climate and how it affects building materials helps you interpret what your stud finding methods are telling you. The tools you choose for mounting, once you've found your studs, matter as much as finding the studs themselves. A pilot hole drilled into the stud prevents the wood from splitting and makes screw installation easier. The pilot hole should be slightly smaller than the screw's shaft diameter. For heavy items, using appropriate fasteners, lag screws, structural screws, or through bolts ensures your mounting can handle the load. The stud finding is only the first step. Proper installation technique completes the job safely. Different wall surfaces require different approaches. Textured walls, smooth walls, painted walls, and wallpapered walls all interact differently with various stud finding methods. Heavy orange peel texture might make the flashlight method less effective because the texture obscures subtle seams. Glossy paint might make baseboard nail holes harder to see. Wallpaper can hide everything, but the knock test and magnet method work through virtually any surface finish, which is why they remain popular despite being simple, non-electronic techniques. Whether you use electronic tools, manual techniques, or a combination of both, the goal is the same: finding solid framing to safely support whatever you're hanging. The methods we've covered represent accumulated knowledge from generations of builders, carpenters, and DIers who needed to attach things to walls reliably. Each technique has situations where it excels and situations where it's less useful. Building a mental toolkit of multiple approaches gives you flexibility to handle whatever wall you encounter.